Today's environmental site managers have many tools to choose from when conducting site characterization and remediation. Geophysical tools can provide non-invasive ways to see inside the Earth, much like how medical imaging lets us see inside the human body. The Usgs Scenario Evaluator for Electrical Resistivity, or Seer, is a quick and simple tool practitioners can use to assess the likely outcome of using two-dimensional electrical resistivity imaging for site characterization and remediation monitoring. Electrical resistivity imaging is a widely used geophysical method for environmental site management studies. The method is sensitive to fluid conductivity, interconnected porosity, saturation, clay content, and metallic materials. But is 2D electrical resistivity imaging the right tool for your project? This depends on the site properties, the goals of the survey, and the survey design. The Scenario Evaluator for Electrical Resistivity, or Seer, is a spreadsheet-based tool that allows the user to simulate conceptual site models for electrical resistivity imaging. Usually when you go into the field, you have an idea of what you are looking for, and you know something about the site geology and hydrogeology. With this information, you can use Seer as a type of quick geophysical feasibility study to see if electrical resistivity imaging is the right tool for the job. First, you use your site conceptual model to create a model of the anticipated electrical resistivity conditions at the site. Then, you use this to create a hypothetical dataset like what you would expect to collect in the field, which is called a forward model. Next, you analyze the hypothetical dataset as if it were actual data collected in the field, giving an inverse model that provides a realistic idea of the best obtainable result from a geophysical survey in the field. Although you might assume the inverse model would always match the true resistivity model we created based on our conceptual model, it inevitably will not. Unlike in popular movies, real-world geophysical surveys don't provide magical 20/20 vision of the Earth's subsurface, but instead provide images that can be blurry and imperfect, yet still useful. Let's see how desktop feasibility studies with Seer can help you decide whether electrical resistivity imaging surveys are a go, no-go for a particular environmental investigation. The Seer Spreadsheet allows the user to select a survey design to model. Using drop-down menus, the user can select from common study scenarios, such as delineating dense non-aqueous phase liquid, DNAPL, or light non-aqueous phase liquid, LNAPL releases in the subsurface, or imaging an underground storage tank. Select electrode spacing and survey geometry. Estimate measurement errors to give us something close to real-world results, and decide where to add borehole electrodes. Then, you click on Simulate to compare the true resistivity model and the predicted inversion results. This will give you a sense of whether your target is likely to be resolved using a given survey design. In another example, you can experiment with a survey design to detect a conductive DNAPL plume. First, model a survey using only surface electrodes. Next, model the same target in survey, but add borehole electrodes. This example shows that, in this scenario, you might want to add borehole electrodes in order to develop a more accurate model of the subsurface conditions to inform remediation. However, our project sites are more complex and electrically heterogeneous than the simple example models shown so far. That is why Seer allows you to freely manipulate resistivity values in cells of the worksheet. You can change the target's shape, extent, and depth, or the electrical resistivity of the surrounding earth materials, and immediately view the effect on the predicted results. Detailed help files provide instructions on how to use Seer, as well as background information on electrical resistivity surveys and modeling. Seer can provide environmental site managers with a quick and easy mini-feasibility study to assess realistic outcomes from electrical resistivity imaging for site investigations and remediation monitoring. Seer and additional documentation are available from the USGS website.